One of the most remarkable foods for longevity in people over 75 may already be sitting in the refrigerator, often overlooked and frequently overshadowed by eggs. For many years, eggs have been promoted as a benchmark source of protein. They contain essential amino acids, choline that supports brain function, and fat-soluble vitamins. Yet an important question remains: what happens inside the human body after the age of 75? Aging is not simply an extension of youth, it represents a major metabolic transition. Muscles become less responsive to protein-related signals. Bone structure gradually becomes more fragile. Immune responses weaken. At the same time, the microbiome, the internal ecosystem responsible for nutrient absorption and inflammation control, grows increasingly delicate. At this stage of life, the objective may no longer be protein alone. Instead, the focus shifts toward nutritional precision. An orthopedic surgeon who spends decades repairing hips, stabilizing spines, and reconstructing knees often notices recurring patterns. Certain individuals heal more effectively. Some maintain stronger bones. Others preserve greater muscular stability. Emerging evidence suggests that a specific type of aged cheese, rich in highly absorbable protein, vitamin K2, and compounds involved in bone signaling, may provide advantages over eggs when it comes to supporting muscle and skeletal resilience after 75. Not because it contains more calories, not because it is fashionable, but because it appears to communicate more effectively with aging tissues at the biochemical level. One of the most important biological changes after 75 is a process known as anabolic resistance. Although the term sounds complex, the principle is straightforward. Muscle tissue gradually becomes less responsive to signals that normally stimulate growth and repair. In younger individuals, even moderate amounts of protein can activate muscle protein synthesis, the cellular process responsible for maintaining and rebuilding muscle fibers. With advancing age, however, the same amount of protein generates a weaker response. The signaling system becomes less sensitive. Research conducted at the University of Texas Medical Branch, along with later findings published in the American Journal of Clinical Nutrition, showed that older adults require a higher leucine threshold to maximize muscle protein synthesis compared with younger adults. Leucine is one of the 3 branched-chain amino acids. It functions like a molecular ignition switch. Without sufficient amounts, the muscle-building process does not fully activate. This is where aged cheese becomes particularly relevant. Varieties such as Parmigiano Reggiano contain exceptionally concentrated levels of leucine. Ounce for ounce, they provide a dense supply of this important amino acid. An additional transformation occurs during the aging process. Over 12, 24, and sometimes 36 months, enzymes gradually break down casein proteins into smaller peptide fragments. Through fermentation and aging, the protein becomes partially processed before consumption. A useful comparison can be made with starting a fire. Eggs offer solid logs that provide excellent fuel, but require more effort to break down. Aged cheese resembles kindling, smaller pieces that are easier to ignite and utilize. After 75, digestive efficiency often declines. Production of stomach acid decreases. Pancreatic enzyme output may also fall. As a result, extracting amino acids from whole foods becomes more challenging. Protein that reaches the body in a partially hydrolyzed form may therefore hold an advantage. From an orthopedic perspective, recovery after a hip fracture depends on more than bone stabilization. Muscle restoration strongly influences long-term outcomes. Study after study identifies muscle mass as one of the strongest predictors of recovery, mobility, and independence among older adults. Sarcopenia, the progressive loss of muscle associated with aging, is not merely a cosmetic concern. It directly affects survival and function. This leads to a critical question. Are older adults reaching the leucine threshold at every meal? Research indicates that individuals in this age group may need between 2.5 and 3 grams of leucine per meal to fully stimulate muscle protein synthesis. Achieving this target often requires 30 grams or more of high-quality protein. For those with reduced appetite, that goal can be difficult. However, 2 ounces of concentrated aged cheese may deliver a substantial leucine boost within a relatively small serving. This does not suggest unlimited cheese consumption. Moderation remains important. Yet adding a modest portion alongside vegetables, legumes, or even eggs may strengthen the overall anabolic signal. Many older adults consume only a light breakfast, perhaps toast and tea. A strategically chosen leucine source at the beginning of the day could alter the quality of protein signaling without necessarily increasing total food intake. The discussion is not about eating more. It is about making food choices that align more closely with the biological realities of aging. Muscle serves as metabolic protection. It helps regulate glucose levels. It reduces fall risk. It supports independence. The challenge associated with aging is often a decline in cellular signaling. Restoring that communication may help preserve physical function. Bone health presents another important consideration. After 75, the issue is often not a simple lack of calcium. Many older adults consume adequate amounts. The challenge lies in directing calcium to the correct destination. Calcium may begin accumulating within arterial walls while bone tissue simultaneously loses density. Osteoporosis and vascular calcification frequently progress together. This is where vitamin K2 becomes highly significant. Most people recognize vitamin K1, found in leafy green vegetables and essential for blood clotting. Vitamin K2, particularly the form called menaquinone 7, performs a separate role. It activates proteins such as osteocalcin and matrix Gilat protein. These compounds function as biological traffic directors, helping move calcium into bones while limiting accumulation inside arteries. Without sufficient vitamin K2, calcium circulates with less guidance. Fermented and aged cheeses contain meaningful amounts of vitamin K2 because the bacteria involved in fermentation naturally produce it. Eggs remain nutrient-dense foods, but they generally contain lower levels of vitamin K2 by comparison. A major investigation from the Netherlands known as the Rotterdam study followed thousands of participants and found that higher dietary intake of vitamin K2 was associated with reduced arterial calcification and lower cardiovascular mortality. The findings represented a biologically meaningful relationship. The implication is noteworthy. A single food may contribute to bone remodeling while also supporting arterial flexibility. Orthopedic surgeons routinely observe the direct effects of bone fragility, including fractures, spinal compression, and joint deterioration. They also recognize the importance of vascular health in determining healing outcomes. Arteries must supply oxygen and nutrients to recovering tissues. Bone regeneration itself depends heavily on blood flow. This raises an important question. What nutritional signals are guiding calcium inside the body? Aged cheeses such as Gouda and Parmigiano Reggiano provide vitamin K2 in a form that is readily available for use, especially when aged for longer periods. The fermentation process represents more than a traditional culinary practice. It creates meaningful biochemical changes. None of this suggests that calcium supplements are unnecessary or that eggs lack value. Eggs continue to provide vitamin D precursors, choline that supports cognitive function, and complete protein. However, after 75, nutritional synergy becomes increasingly important. Consuming calcium without adequate vitamin K2 may be comparable to having building materials without a construction plan. A practical approach includes combining calcium-rich foods with natural sources of vitamin K2, such as aged cheeses and fermented foods. Adequate vitamin D remains essential because it enhances calcium absorption, while vitamin K2 helps determine where that calcium is ultimately deposited. Physical activity is equally important. Mechanical loading through resistance exercise stimulates osteoblasts, the cells that work closely with vitamin K2-dependent osteocalcin. Nutrition alone does not complete the signaling process. Movement remains a necessary partner. Bone health is therefore not simply a matter of density. It is the result of coordinated biochemical communication throughout the body. Bone carries a record of many years of nutrition, physical activity, and inflammation. Yet there is encouraging news. Bone remains living tissue. Even during the 8th and 9th decades of life, remodeling continues. Osteoblasts remain responsive. The important question is simple. What signals are they receiving? As the body ages, changes occur not only in bone and muscle, but also within the microbiome. Fermentation may provide one of the least recognized benefits associated with aged cheese. Inside the human body exists an ecosystem weighing approximately 3 pounds. It contains trillions of microorganisms. By age 75, this internal environment has undergone substantial change. Microbial variety decreases. Helpful bacterial strains become less abundant. Organisms associated with inflammation may gain influence. This process, often referred to as inflammaging, can gradually elevate systemic inflammation, weaken immune performance, and reduce nutrient utilization. The gut is more than a digestive passageway. It functions as a communication hub linking the outside environment to the immune system. This is where fermentation reveals its biological value. Aged cheeses are not merely concentrated sources of protein and fat. They are products shaped through microbial activity. During fermentation, bacteria digest lactose, partially break down casein, and create bioactive peptides. These small protein fragments may influence blood pressure regulation, immune communication, and antioxidant mechanisms. Fermentation can be viewed as an added layer of biological refinement within food. Earlier in life, digestion is generally strong. Stomach acid levels are robust. Pancreatic enzymes are plentiful. After 75, however, stomach acid production may decline significantly. This condition is known as hypochlorhydria. When this occurs, protein breakdown becomes less efficient. Larger protein structures may pass through the digestive tract without complete digestion, potentially reducing amino acid uptake or causing discomfort. Aged cheese arrives in a different form. Long-aged varieties such as Parmigiano Reggiano contain very little lactose and proteins that have already undergone substantial hydrolysis. As a result, many older adults who experience difficulty tolerating milk often find these cheeses easier to consume. There is another interesting aspect. Certain peptides generated during cheese fermentation have demonstrated ACE-inhibiting activity. This means they may provide gentle support for maintaining healthy blood pressure. Research conducted in Japan and Europe has identified these bioactive compounds in fermented dairy products, suggesting that aging transforms milk into something functionally different from its original form. Eggs provide complete nutrition, but they do not undergo fermentation. They lack this microbial transformation process. Consider the digestive system at 80 years of age. Appetite may be reduced, enzyme production may be lower, the microbiome may be more vulnerable. Under those circumstances, foods that are concentrated, efficient, and naturally pre-processed may offer strategic advantages. This does not require large servings. 1 to 2 ounces paired with fiber-rich vegetables can create meaningful synergy. Fiber nourishes beneficial microbes. Peptides contribute amino acids. Fat assists the absorption of fat-soluble vitamins. Traditional cultures rarely consumed cheese in isolation. It was commonly accompanied by olives, leafy vegetables, and legumes. The microbiome flourishes when diversity is present. A deeper lesson emerges here. Aging is not simply a matter of deterioration. It also involves changes in communication among biological systems. The gut communicates with bone through immune pathways. It communicates with muscle through inflammatory signaling. It communicates with the brain through the vagus nerve. When microbial balance is maintained, repair mechanisms throughout the body tend to function with less resistance. A practical approach to longevity may therefore include modest portions of fermented foods each day, including cheese, yogurt, kefir, and sauerkraut. Combining these foods with plant-derived fiber helps support microbial diversity. Excessive dietary sterilization is not the objective. Variety promotes resilience. The aim is not sterility. The aim is balance. Aging is often viewed as unavoidable decline, yet part of the process may reflect ecological imbalance within the body itself. When the ecosystem improves, the environment that supports healing may improve as well. Attention now turns to a more structural question. Specific peptides derived from dairy may directly influence osteoblasts, the cells responsible for building bone. Supporting bone is not only about supplying minerals, it also involves activating living tissue. When an orthopedic surgeon examines bone, they do not see something inert. They see living architecture. Bone remains metabolically active throughout life. Osteoclasts continuously remove old tissue while osteoblasts generate new tissue. This cycle of renewal persists even beyond 75. The challenge is not that reconstruction stops, rather, the balance changes. Breakdown gradually exceeds rebuilding. This raises an important question. Can nutrition influence the cells responsible for construction? Emerging evidence suggests that certain dairy peptides, especially those created through fermentation and aging, may encourage osteoblast activity. Casein phosphopeptides, for instance, have been shown to improve calcium absorption within the intestine. Lactoferrin, another protein originating from milk, has demonstrated osteoblast-supporting effects in experimental settings. These findings present dairy in a different light. Rather than serving solely as a calcium source, it may function as a signaling network. Laboratory research published in journals such as Bone and Osteoporosis International has observed increases in markers associated with bone formation following exposure to bioactive milk peptides. Although this field continues to develop, the overall direction remains noteworthy. Food appears capable of communicating directly with bone cells. Consider the distinction between taking a calcium supplement and consuming a fermented aged cheese such as Gouda. A supplement provides an isolated mineral. Aged cheese supplies minerals, protein structure, fat-soluble vitamins, and signaling peptides within a unified biological framework. It resembles the difference between delivering construction materials alone and delivering those materials together with skilled workers and detailed plans. Eggs offer excellent quality protein. They contribute to muscle maintenance. However, they do not contain meaningful calcium levels. They also do not provide vitamin K2 in the concentrations commonly found in aged fermented cheeses. Eggs remain exceptional foods for many purposes, yet aged cheese presents a distinctive combination of factors related to skeletal signaling after 75. There is another practical consideration. Bone responds to three primary influences: mechanical loading, hormonal conditions, and nutritional signaling. When one of these elements is absent, remodeling becomes less effective. Following menopause and andropause, hormonal changes accelerate bone loss. This is a normal biological process. Mechanical loading through resistance training, uphill walking, or carrying groceries stimulates osteoblasts through mechanotransduction pathways. When these activities are combined with nutrients that support osteocalin activation and collagen production, the signal becomes stronger. Older adults who remain physically active frequently maintain better posture and experience fewer fractures. This pattern is not accidental. Bone responds to stress. A simple framework for skeletal resilience after 75 may include consuming small servings of aged fermented cheese several times each week to obtain vitamin K2 and bioactive peptides. Resistance exercise can be performed 2 to 3 times weekly. Adequate vitamin D status may be maintained through sunlight exposure or supplementation under medical supervision. Total protein intake should remain sufficient, approximately 1.0 to 1.2 grams per kilogram of body weight unless medical circumstances indicate otherwise. The goal is not excess. The goal is coordination. Bone represents memory, but it also represents opportunity. Another challenge associated with aging is often overlooked. Appetite gradually diminishes. By the 8th decade of life, many individuals experience what geriatric specialists describe as the anorexia of aging. Taste sensitivity decreases, sense of smell weakens, gastric emptying slows. Hormones involved in hunger regulation, including ghrelin and leptin, shift from their previous patterns. Meals often become smaller without intention. Yet nutrient demands do not decrease. Protein requirements frequently rise because of anabolic resistance. Calcium remains essential. Vitamin D becomes even more important. The margin between adequacy and deficiency grows narrower. This creates a practical challenge. How can stronger biological signals be delivered through smaller amounts of food? Nutrient density becomes increasingly valuable. 2 large eggs provide approximately 12 grams of protein. High-quality protein remains essential. Yet for an older adult who consumes only a light breakfast and a modest evening meal, reaching 90 grams of protein daily can become difficult. Now consider a small serving of 2 ounces of a long-aged cheese such as Parmigiano Reggiano. Within that compact portion, there are approximately 20 grams of protein, a concentrated supply of leucine, calcium, vitamin K2, and fat that slows stomach emptying. This allows amino acids to be delivered over a longer period. A small serving can create a substantial biological signal. This is not an argument for excessive saturated fat intake or unrestricted consumption. The broader dietary context remains important. Overall eating patterns matter. Cardiometabolic health matters as well. However, when incorporated thoughtfully alongside vegetables, legumes, olive oil, and regular movement, aged cheese can function as a useful nutritional tool rather than a disadvantage. There is also a deeper metabolic consideration. After 75, unintended weight loss is often viewed as a warning sign. It is associated with frailty, increased hospitalization risk, and higher mortality. Preserving lean tissue becomes protective rather than cosmetic. Muscle serves as a major glucose reservoir. Bone provides structural support. Stable body weight becomes an indicator of resilience. Many older adults who are slightly more robust, neither overweight nor undernourished, often recover more effectively from illness. Energy reserves have value. Nutrient-dense foods can help guard against undernutrition. A practical framework begins with building each meal around a high-quality protein source. When appetite is limited, density becomes more important than volume. Choose foods that add nutritional value rather than empty calories. Olive oil, nuts, and aged cheese can contribute in this way. Relying primarily on refined carbohydrates may provide energy, but offers limited structural support for the body. Within longevity research, considerable attention has been given to mTOR, a growth-related pathway activated by protein intake. Researchers including Walter Longo have demonstrated that chronic overactivation of this pathway may contribute to accelerated aging. Yet an important distinction must be recognized. Undernutrition in advanced age presents its own danger. Longevity after 80 is not centered on minimizing growth signals at all costs. The priority shifts toward preventing frailty. Strategies evolve across different decades of life. During midlife, moderating excess may support a longer lifespan. In later years, targeted nourishment may help preserve health span. This reflects biological timing. A useful question therefore becomes whether current protein intake matches the needs of the present stage of life, or whether nutritional habits are still based on recommendations intended for someone 40 years younger. Aging requires adjustment. Wisdom often involves recognizing when a different approach is necessary. Looking beyond protein totals and vitamin content reveals a broader concept. Food acts as information. Each meal influences pathways such as mTOR, AMPK, sirtuins, and IGF-1. These are not merely scientific labels. They function as biological switches that influence growth, repair, energy conservation, and cellular cleanup processes such as autophagy. During youth, growth tends to dominate. In midlife, maintaining balance becomes increasingly important. In advanced age, resilience takes priority. For many years, longevity research, including influential work from Walter Longo, has emphasized moderating excessive protein consumption during midlife to avoid continuous activation of mTOR, a pathway linked to accelerated aging when persistently elevated. However, an important nuance is often overlooked. After 70 or 75, the biological landscape changes. IGF-1 levels naturally decrease. Muscle mass declines. Bone density diminishes. Recovery becomes slower. Under these circumstances, carefully increasing high-quality protein intake may reduce frailty and lower mortality risk. Multiple epidemiological studies have reported that greater protein consumption among adults older than 65 is associated with improved survival outcomes. This differs from observations made in certain middle-aged populations. The difference is not a contradiction. It reflects timing. Imagine a dimmer switch controlling light in a room. During midlife, brightness may be excessive and require reduction. In later life, illumination begins to fade and may need to be increased again. Aged cheese fits within this framework not because it possesses extraordinary powers, but because it delivers nutrients efficiently. It supplies concentrated amino acids capable of activating mTOR sufficiently to support muscle repair, especially when paired with resistance training, without requiring large meal volumes. It provides vitamin K2 to help direct calcium appropriately. It contains peptides that may assist healthy blood pressure regulation. It also contributes calories that may help prevent unintended weight loss. At the same time, context remains essential. Aged cheese consumed within a dietary pattern rich in vegetables, legumes, extra virgin olive oil, nuts, and physical activity represents nutritional synergy. The same food added to a sedentary lifestyle dominated by refined carbohydrates creates imbalance. Longevity depends on coordination among many factors. For adults older than 75, a biologically informed framework may include approximately 25 to 35 grams of protein at each meal, adjusted according to body size and professional medical guidance. A concentrated source of leucine should be included. Aged cheese can serve as one option. Protein intake can be paired with resistance exercise or weight-bearing activity during the same day. Metabolic flexibility may be supported by avoiding continuous snacking and allowing periods when AMPK and cellular repair pathways become active. Nutrient density should take priority over sheer quantity. Nutrition advice is often presented as though it applies equally to everyone, yet biology changes with time. There is a season of growth, a season of peak performance, a season of recalibration, and a season focused on preservation. After 75, the goal is no longer maximum muscle size or peak metabolic intensity. The objective becomes maintaining independence, protecting cognitive function, reducing the likelihood of falls. Food becomes a strategic tool. Returning to the original claim that one cheese may be 1,000 times better than eggs after 75 reveals a different conclusion. The central issue is not superiority. It is suitability. Eggs remain an exceptional food. They provide choline that supports cognitive health, lutein that benefits the eyes, and complete protein that assists tissue repair. They are versatile, widely available, and highly nourishing. Yet after 75, biological conditions change. Muscles respond less strongly to stimulation. Bone remodeling slows. Appetite decreases. The microbiome shifts. IGF-1 levels fall. The risk of frailty increases. Within that environment, certain foods gain strategic value. Aged fermented cheeses such as Parmigiano Reggiano and Gouda provide a unique combination of characteristics. They deliver concentrated leucine capable of helping reach the anabolic threshold. They provide vitamin K2 that helps direct calcium toward bone tissue. They contain bioactive peptides produced through fermentation. They offer compact caloric density that may help prevent unintended weight loss. And they exist within a nutritional matrix that interacts efficiently with aging physiology. These cheeses are not universally superior. However, within this particular decade of life, they may be especially well matched to biological needs. That distinction is important. Longevity is not governed by rigid rules. It depends on adaptation. For many years, aging has been described primarily as decline, a gradual loss of muscle, bone strength, and vitality. Modern research presents a more optimistic perspective. Even during the 8th and 9th decades of life, osteoblasts remain active. Muscle fibers continue responding to resistance exercise. The microbiome retains the ability to diversify. mTOR can still be activated strategically and later allowed to rest. The body remains responsive. A practical step can begin with one deliberate act of structural nourishment. It may involve adding a small serving of aged fermented cheese to a vegetable-rich meal. It may involve starting a gentle resistance training program using light weights, resistance bands, or chair squats. It may simply involve reassessing daily protein intake from a new perspective. An important question remains. Are you eating merely to sustain life, or are you eating to strengthen resilience? Food is more than fuel, and it is instruction. It is structure. It provides the body with the resources needed for renewal. When nutrition is aligned with the biology of a particular stage of life, a meaningful shift can occur. The goal is no longer to resist time. The goal becomes working with it. Take a moment today to evaluate the quality of your nutrition, your protein intake, and your daily movement habits. Share this information with someone who may benefit from it and continue exploring evidence-based approaches that support strength, independence, and long-term vitality throughout every decade of life. Please leave your thoughts about this content in the comments below. Thanks for watching. See you in the next one.